Right. Hi, everybody. Welcome to the second part of the 3D generative adversarial networks. This is part of a tutorial series, like complementary or like support material for the students of the Design Intelligence class that is being taught at MIT for the fall semester spring 2022. Um, it's a class where I am part of the teaching staff with and co-teaching this class with Marcelo Coelho. Um, so yeah, what you're going to see basically from now on is like a series of or basically if you are subscribed to my YouTube channel that I'm gonna show now, um, the I've been posting some material related to the class, for example, gesture recognition, transfer learning, how to implement like a server to actually serve ML models to basically like any software. Now I'm doing this series of tutorials about 3D model generation. So if you were if you are subscribed, you probably saw a notification
Let's just create a couple of
where I'm
panels.
in this video. In the first part, I'm teaching how to create your own dataset. Basically, to create and automate the process of exploring a let's say a design space based on the parameters of an object, sampling that design space using the digital structures plugin. Basically, we're doing some Latin hypercube sampling, and then in the last part, we are actually creating with a simple Python script. We are writing um, basically like n amount of meshes that we want for our dataset. In this case, it was just like a simple like table, for example. It could be like whatever. It could be a house. It could be like whatever model that you actually want to train. And this is super important because, as I explained in the video, most of the implementations for 3D GANs uses like datasets that are already there. You know, like ShapeNet or Thingy 10K, and so on and so forth. So if for us as designers, it's very important that we actually um, we want to express ourselves. So it's very important that we can basically work with our own data, right? With our own production. So we are gonna use a couple of tools today. We're gonna write a very simple Python script, but what I want you to do, because now that we have, let me show you this. Um, Now what you see here on the screen, right? It's a directory with a lot of OBJ files. Um, and probably if you saw the first part of the tutorial, you saw that I was using Mac because I wanted to go over the, at least the first part using Grasshopper, that you can do this using a Mac. Um, but in this part, I mean, I will add probably like a bonus series to teach you how to do what we're going to do today, but on a Mac. Sadly, I'm having problems to replicate this, the content that we're going to see in this part on a Mac because I don't have an Intel Mac. I have one of the new ones with an M1 chip, and that presents some incompatibilities with the process. So we want to stick or we want to use Windows for this part. I mean, I can do it on using Parallels on my machine. What we're going to do today, like processing and voxelizing all the models. But I will highly recommend that you do this on Windows because it's way easier. So to do that, if we Google Binvox, we will see that Binvox is it's basically a straightforward program that reads a 3D model file and basically it turns it into a binary voxel grid. It does like some sort of like slicing. Um, it's a project like an independent project. Apparently, it was to the aim of this was to generate like some sort of like Minecraft type of style based on like any 3D model. and it takes like many formats, including DXF, PLY, STL, Polygon, basically with Polygon information, and you can output this, as it says here, as a Binvox, as Mira, or Minecraft format, and others, right? Um, there is a, yeah, I think there is a, yeah, there is a paid version that you can do 4096 by 4096 by 4096 voxels resolution. So basically it's a space that is filled with boxes, that voxels actually, but we don't need that resolution because one of the things that we're going to learn, not in this part but in the following, when we are ready to actually train and work with our data, um, we need probably like a much lower, I mean, we need a lower resolution, like probably like 32 to 64 um, voxels. Maybe if we have a beefy GPU, basically like a very powerful GPU with a lot of RAM, so we can basically increase the batch size to train our model, we can do 128. But that is, I mean, unless you're paying, for example, like for cloud computing, even like a Google Colab Pro or Google Colab Pro Plus, where you can access like one of the best GPUs that they offer, I will recommend to stick with 64. So one of the things that you want to do is to find the versions. Again, with Linux, it works. I can also, if for the ones, if you're interested, like post a comment. Of course, try to subscribe to see when I'm releasing the other parts of the tutorial. Um, I can show you how to use it on Linux. On Mac, I will try to do it if I can get to make it work, because right now it's like compile under El Capitan, so it will use Rosetta compatibility layer, and for me it gave me a couple of errors. So this is why I'm not covering that. And also you need to install another thing that is called Xquartz. So it's a little bit more complicated. For Windows, you just need to download this file here. It's a Windows executable, and be careful because usually antiviruses, they will think that this is a virus. I checked the file many times and it doesn't have any virus. So um, so be careful. So now what I'm going to do, I'm going to show you actually the, so basically this is the website for it, and you can see here yeah, like all the explanations of what this is. It has a Binvox wiki where you have like a couple of um, interesting information. But again, what I want you to do is to, yeah, don't look at the Linux or Mac, just go to Windows executable, and you will download this file that is over here. It's a binvox.exe, right? It's an executable. And this gives you actually a couple of information, a couple of things. I think there is one where it shows you how to use the Binvox. I think it was here. To Windows, so command, which means, yeah, I mean, this is also something that we need to do. Binvox is a command line tool, which means it must be run from a common shell. So yeah, you cannot, it doesn't have a GUI, right? So it's just that we need to call it. So we will see a little bit about that. There are two options. I will show you a way that it's more automatic. There are two ways to do everything directly on your browser. Sorry, on your directory using the command line. I'm not a huge fan of that. So this is why we're going to write a small Python file. So once you have Binvox, I will put the link in the description of the video. Once you have that, you also want to go and download this. This is Binvox RWPy. It's a code from Daniel Maturana. robotic scientist at CMU, I think. So basically, he automated or created a small code to actually work with Python. Sorry, with Binvox files. And also, you have a way to visualize those. We're not going to use that, but it's like very simple. It just like does whatever exactly what we need to do. Is the process automated, and and we can use it, but we will see like an alternative way. But I mean, we will use it, but not the full functionality. I will show you something else because I had also some errors just trying to use this. Probably, I mean, someone knows better. This is the way that I do it. So, but here you can see that basically like the in this part of the screen, the format is just like a three-dimensional array with just true or false values, meaning that true is where you have a voxel and false when you don't have a voxel. So it's a very simple format, and models that are, for example, like um, hundreds of kilobytes or megabytes could be reduced to just like a couple of kilobytes. So that is also very convenient because you can have like huge data sets for like, I don't know, ShapeNet, for example, is 75 gigabytes of information. You can reduce it to like 500 megabytes or something like that. So it's like very also convenient to do. And the best thing is that you don't have to use that annoying MATLAB format that scientists use for previous implementations. So enough chat, download both. Basically, it's just like this file here. You can just clone the repository or download the file. Um, Let me just turn this off. So once you are in Visual Studio Code, you want to open a folder. I'm just gonna create a new folder here. Um, I will call like dataset process. I will select the folder. I'm using Visual Studio Code. I'm not gonna go over this because we already covered this in other videos. So what you want to do is actually just give me 1 second. Right. So what you want to do is first copy some files. So let me just put those files. We'll just copy the file that we just downloaded, the Binvox file. We also want to copy the Binvox executable here, and we want to at the same time, and this is a nice feature of Visual Studio Code. Here I have just a folder with OBJ. I'm using for this purpose. I'm not going to use. I mean, I'm just going to use a folder with like the typical like chairs, for example, right? So I'm just gonna drag this. I have this in one of my hard drives in my desktop computer, and Visual Studio Code has a nice feature that you can create workspaces, so you don't need to actually like copy this folder, but you just add it to the workspace. So, uh, and actually this is not the folder that I wanted. So, because this already has some Binvox files process, so let me do a quick fix. Alright, so now this is the folder that I wanted. So this is a folder that is called chairs. It has a lot of 3D models with chairs. It's basically like the same thing that we produced in the last video, in the first part of the video. So what we want to do now is we are going to create a Python file, and we will process these models based on on this again script. So Binvox is just an executable. We need this because it's the one that we will use to process some stuff. I think we're gonna use it. If not, again, it doesn't matter. So in this case, if we're not using it here, we will use it for the training process to actually read the models. So it doesn't matter. So let's just create like dataset or process binbox .py. And again, this is super fast. So this tutorial, I mean, I've talked a lot, but it's good so you have context about what's going on. So import OS, we will do some import, for example, like subprocess. We want to also do like import numpy, and this is important. Probably for this we need to create an environment so we can install numpy if we don't have it already in our system. So we will do that, but we need numpy, and we will just in case import also. Again, I don't know if we're going to use it, but you see that because this file is already here, the Binvox rw read and write, it's here, we're gonna just import it just in case. We need a couple of simple things, just like we're gonna call it like ds path, that this will be the path to our dataset. So for that, we'll create we need to actually indicate what is the folder. So here we can just set like copy path and just paste this. And again, Windows has some like things with slashes and backlashes. So in this case, I'm using this directory that is has like ShapeNet files, OBJ, and chairs. It could be your directory where you your folder where you store all your OBJ from Rhino. That is fine. So path to folder with OBJ files. That is cool. We will do actually this is very simple. So let's just write the definition. We will say like generate voxels, and here we will call this like the obj file, or let's just call it model file. And here we need to just do the following thing. We'll say like OS system, and we can write the command to do the Binvox stuff. So Binvox, so actually it will be good to do let me do this. Let me just reveal it in Explorer. And so if I do this, let me check if we are, it's visible on screen. This is a terminal, and if I see the content, and if I do Binvox, oops, why? Binvox.exe. It's weird that this is not. Oh, sorry. It's because of the shell that I'm using. Yes, here. So if I execute this, the binvox.exe file, you will see that we have a lot of parameters. So the way it says like the usage for this, you can read it now better because it's bigger on screen. The typical usage is you write the instruction binvox, then is you specify like the voxel dimension, 32, 64, and so on and so forth. The type of voxels, basically like what is the format type. Default is binvox, but again you have other formats for VTK, Mira, and so on and so forth. And also you have, for example, like the method for doing this. So basically this will do like some slicing and generate voxels based on that. And you have other like specific um, parameters, for example like CV, so it centers the model inside the unit cube. um, you can rotate, so remember that we rotated stuff in the past tutorial in Rhino, so we don't need that, but if you didn't do it in Rhino you can do it here. And things like that. So we will use, so for example here you have one specific um, format to use, right? So we will do that. We will just write um, in this case Binvox minus CV minus fit minus MB. We will see again minus D. So in this case we will use 32 voxel resolution so that the processing is faster. I will recommend doing 64, but again it takes more time. So plus str, and here we will pass the model file. So this is the only instruction that we need to actually. So again, if we go to our PowerShell, we're using a couple of options here. The CB is like the center of the model. The fit, only write the voxels in the voxel bounding box. So yeah, we optimize a little bit the process. The MB, when converting from OBJ to schematic, yeah, I don't remember what was this option actually. Uh, minus E, exact voxelization. Um, Actually, we can use this also to get more precision, but it does not use like the graphics card as said here. So it was doing the process a little bit like slower. If you want, you can get rid of the minus MB. The minus D is the dimension. So again, the maximum for the free version is 512. The default is 256. And then we just need to specify what is the model file that we're using. So now this is as simple as this. We can do a couple of things here. So for example here, say like if ds path minus 1 not equal to, I mean this is always the struggle with the things with paths and on Windows versus Unix systems, so that's cool. We will say ds path, and here we'll say for I in OS dot because we want to iterate over our ds folder. So we will say this for each basically like element in our data set, like the folder with the obj files. We will just call the generate voxels, passing the ds path plus the name of the or the name of the file, but we need to cast it as a string so we don't get an error. So let's see if this works, and if this works I will show you another way to do it. This is like the more like manual way to do it. It requires a couple of other things. So what we can do here is just open a new terminal. Yeah, we're gonna open it here. I'm just gonna check a couple of things. For example, if I have numpy install, import numpy SMP. Yeah, we have numpy. So what is going on here? I have the terminal. I open the terminal in Visual Studio Code, as you can see like down below, and you have a couple of options. So also like do like conda and list if you have Anaconda environments, and for some reason, oh, again, it's this. Sorry, I'm jumping between like different Anaconda prompt. Let me just open the Anaconda prompt. So if I do conda environment list, you can create your own, for example, environment. Again, I'm not going to cover this because I already did in another video and also in class for you. So you can also start your own environment too, and it's the recommended thing actually. So in this case, what do I have here? Like whatever, I'm not going to do it in this tutorial. I don't want to extend more. So we have NumPy. I'm going to execute this. Yeah, just focus. So I'm going to do Python. First, let me check that we have the files. Yeah, so we see the files here. Preprocessed Binvox. So we're going to say like Python 3 Binvox.ex. No, sorry, not this. Process. Sorry, process Binvox. So you see what's going on now. It's processing our models. So it's generating all of our Binvox files. But there's something not working here because we should see one thing. But at least we know that we are calling for every file. For every file, we're actually calling I mean, we're calling it correctly. So let's just do let's just check the code so we can see it. Okay, so always check. I found the error. I had like this one was a backslash. So yeah, and you need to add also the slash at the end. So yeah, this is the code. I just added a here, like printing just the file name, so we know that it's processing. So look what is going to happen. If I do this, right, with this line of this command, Python 3, and then pointing at the Python file, and it starts going crazy again. So let me a second, just work. Okay, now it's supposed to work. Sorry about that. You just need to leave a space here after the voxel parameter. So if I execute this, you see what's going on here in the right upper part of the screen is just it recognizes your GPU because it uses GPU. In this case, I have a Radeon 7 with plenty of memory. It's like more or less like the performance of a 2080. And it just basically started like scanning, and this is a very slow process. So don't freak out if actually this is it takes a long time, because it does. It's a little bit crazy because it really takes a long time. So you see, it will just start processing your models. You just go for lunch or do whatever you want, and after that you will have a in your folder. So now I guess it's writing all the files here. Let me just should be writing the Binvox files here. For some reason it's not. So let me just cancel this. It's processing, but it's not writing. So let me check what's wrong here. Okay, I just just deleted like additional parameters like the fitting or things like that. It was giving me a problem. It was not writing the Binvox file. So if you see my folder here, I have models. It started writing actually everything. So let's just execute this again. Yeah, so now it's processing, and actually it's doing it like way faster. So you see, as it goes processing, it just like start shooting new models. So this is one way, so you can keep it like centralized, and you can combine this with I guess there is a way to do this. Maybe I will try to integrate this simple code into Grasshopper. So basically you create the OBJ, but at the same time you create the Binvox. um, that is possible. So let me just stop this, because we know that we're already generating the Binvox files. Actually, I'm going to delete this. The other alternative, and this is like a more manual thing. It's a more manual thing. Let me just actually close this. It's just to do the following thing. You can just copy the binbox.exe. You can see it on the screen. I have it here with my mouse, the binbox.exe, and just right click in your folder, open a Windows terminal, and let me make this big. In this case I'm using the PowerShell. So you can just use a command that is actually more automatic. You just need to have this and copy and paste it. Actually, probably this is like more useful. So you can do like the FORFILES /p dot /m. In this case, we're using obj.obj and /c, and here we just do the cmd, because basically we're automating the process of calling a command. Minus /c binvox minus d, we said like, I don't know, like 64 minus t binvox at file minus cd. Yeah, so basically this will automate the process if it works. Oh, I have a problem here. Let me check. It's giving me the argument obj. Why is this yelling at me? It's giving me an error because it doesn't like FORFILES / let me check my notes on this, because I usually use my asterisk.obj. Actually, it's okay. Let me just yeah, it's the exact command. I don't know what's going on. So let me just cancel it. This is the command. It's exactly. Oh, I had the dot. Yeah, the dot needs to be. I was missing a space. This is the typical thing. So you use the FORFILES to automate the process. So basically, it would read like each file on your folder, and it will just like process everything. So this could be the way to actually do it in a better way. So now that we have this, we will go through the last part. So I will just leave this processing. So I will just execute this, and it goes through the same process, just voxelizing everything, and you just leave it there. And after, I don't know, it depends on the amount of data that you have, it will be like fast or not. So I will cancel this because it's a little annoying also, because it's like very manual, and it starts doing like crazy stuff to your window, so it's like a little bit annoying. So check the difference. Like the model 0 was like 200 kilobytes, and now it's like 8 kilobytes because there's a lot of data compression, because this is just like true or falses, right? Um, so the next step for this part, and this is actually quite important, um, is to go to your Google Drive and let's say you want to upload um, your data. So I have a folder 3D GANs. I can put like Binvox data, and here we want to actually upload the Binvox file. So I have a couple here. This is another category from like ShapeNet that is processed. It doesn't matter. I will just, let's say, grab a bunch of those. You want to actually upload all your Binvox files here by category, for example. So I will airplane, we'll create a folder, and I can just like drag this, and it will upload all the data. So that is cool. That works. So the next thing will be doing the following. I will go to Colab. I will start a new notebook. I will call this 3D GANs, like 3D GANs. I'll call this with the design 22 3D GANs. You want to, of course, go to edit. I'm using Google Colab Pro, so I can have access to better processing power. So I'm using GPU. You want, if you're not paying the $10 per month, you will just have access to GPU, not TPU. Those are tensor processing units. That it doesn't matter. Also, you won't have access to high RAM. In my case, I want to have more RAM too, so it doesn't like kick me out. So because I'm using Colab Pro. So we want to do this, and again, we will see if this is working. I'm just starting the session. You want to mount your Google Drive. If you just started the Colab, yeah, you just press that button and it will be there. If not, it will ask you to run a cell here to mount the Google Drive. It takes a little bit, so we can start just coding a little bit of things, right? So we will start with the imports. Imports. So we can do a couple of things here. PIP install Wisdom, because we want to visualize a couple of things. This is PIP install TensorBoard X. So what we will do in the following actually part, that will be next week. The video is already there. I just need to, I mean, next week, because I'm planning in the future. Yeah, it will be released with 1 week of gap. We will go over the code actually of the 3D GAN. So install. This is we will use Open3D to do some things. So actually, the imports will be here. We need to install here. This is the step 1. Libraries. We can install everything here. So you know that we're using terminal commands. So this is why you have the exclamation mark. This is the step 2. Yeah, it's installing everything. So this will be step 2. Our imports. I will add a cell. So we will import OS. import also system. We'll say that from torch that utils, we will import data from torch that autograd import variable. Oops, currently it finished installing everything, and we will import torch, and finally import open3d that we just installed. We'll execute this. Hopefully it won't give us any error. It didn't give us any error. It says that we need to yeah, it's saying something that about like restarting the runtime. So let's do that, and hopefully it will work. Yeah, so it is working. So we have our imports. We're going to use PyTorch. I like PyTorch better than TensorFlow, even though, although TensorFlow is getting like really good now. So now we need to step 3, configure data paths and stuff like that. We can say that our DS directory will be, and we can go to our drive. I have it here, 3D GANs, Binvox data, airplane. Again, it will be, remember, this will be your own folder. So you just need to like right click, and you will see that all the Binvox files are here. So that is good. After we do that, actually, we need to do one more thing. So we will set the file, the DS path here. Actually, no. This should be like more general. Actually, we will do something. We will do this. We will just set the base or the root directory here. So let's just call this like root directory. And then we will say like sys that path that yes, I am using that insert and here we will use the root directory, and here sys that path that append root directory plus src. We don't have it. Yeah, we don't have this yet. So actually, what we want to do here in 3D GANs, we will create a new folder. We will call it src. Why? Because here we will put like all our data. Don't mind this output. I already had it for another training process, but src, it will be the source of our code. So we want to do that. So that should be okay. After that, we want to do a couple of things. We want to actually use here the Binvox. So let's just go to my folder here, src, because we're gonna do this from scratch. The next one will be actually like a long tutorial. Here we're gonna use the Binvox file, this Binvox rw. So I just uploaded it to my Google Drive. If I go to src, src here, I see this file. And we might want to do a couple of things. So once we have done this, actually, we will do like a final step, and we'll leave this part up to here. Step 4 is actually visualize the data just as a sanity check. So we will write just a couple of small like functions. The first one will do the following thing. We will do a couple of more imports. Actually, those imports could be here. We will import Binvox. So if we have it in our root directory, we can import it here. Binvox. Also, we will do import matplotlib, pyplot as plt. This is like very typical, so this is what you see the autocomplete. And also we will import matplotlib dot grid spec, sorry, as grid spec, so we can visualize stuff in 3D. So let's just write the definition. So we will call this definition. It will be called show voxel model, and here we can pass the voxels. The voxels we can do like specify the figure size, fixed size. Yeah, you can say like 32 will be the fixed size. The axis off, remember that we're using in this case matplotlib, so we need to configure that. I have a point that's not supposed to be there. What else would we can do? Specify the edge color. If you want to know more about this stuff, about like colors and stuff, go to the documentation of this. Face color, we can specify here. I think it was deep sky blue. So we'll use that. Alpha 0.5, like the transparency of the thing that we're doing, and also lined with we could be like 0.2. That's fine. This is all we need. Basically, these are the parameters that we will use. So the definition, the function is like very simple. It's just like voxels, voxels that g 0.5. We will just generate. This is just like like typical like pie plot and stuff that I found like super boring. Figure fixed size. It will be equal to fixed size. What else? We can specify here like the grid scale. It will be to let's just call it like, I don't know, like GS is fine. We'll use grid spec dot grid spec. This will be 1 number of columns and rows, and we will use gs.update w space equals 0.05, and horizontal space h space will be equal to 0.05. That is correct. So now we define the x, y, and z. We'll say like voxels that non-zero, 0. And again, pipe plot stuff that I don't like. Actually, I have it in my notes. So I'm just gonna copy because this drives me a little bit crazy when we're doing this type of things. Um, so this is the definition. Let me just do the right indentation. It's just configuring a how's it called, a 3D plot, right? So basically you get the pixels, you configure everything to show in 3D, and basically here you specify how you're going to show the voxels. It's no more than that. So hopefully this is just copy paste from my notes. It should be okay. And now we need to call our voxel visualization. We will move this to a utilities file later, so don't worry. I'm just for this purpose, because I don't want to do everything. We will say like with open root directory plus, and here we need to actually go to our Colab Binvox data airplane, and let's just pick like whatever. Copy this path, and I will delete everything from here, so we can do this. And now we can say, sorry, as file, because we're opening that file, we can say the box equals to binvox read write rw that read as 3D array the file that data. With this, we're reading that binvox file, so we can print also the box that shape just to see what are the dimensions of what we have, and also we can now actually call this function with box, passing the argument box, because all the other arguments are already there. So if we execute this, not an error, and hopefully this won't show an error as well. Of course it show an error. Vox bimbo blah 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 blah. Let me see what the problem is. Probably I made a mistake in the definition, so let me just copy it from my notes. Yeah, everything seems to be the same. Box. Do I have it correctly? Okay, I don't know. I had an error, but basically it's the same. It's like, oh, I didn't specify the RV. Sorry. That's fine. That was the only error. So anyway, you can see that here we're reading the model that we want. So we can change it to another file. These are 64 by 64 by 64. So we have our voxelized models. So it's showing us like actually the size of the thing, and we're getting, in this case, are like voxelized models. You see 64, 64, 64, and everything is fine. So we leave it up to here. Next one will be going inside, basically like we will use a DC GAN implemented in PyTorch, and we will use that DC GAN to actually train our model. So I hope again that you like this. I will post the code for this, and I'll see you in the next part. So thank you very much.